Today we're looking at lesson 3.3, which is rate of change and slope. Rate of change and slope actually mean the same thing. Rate of change is more describing a particular scenario, and slope would be describing the slope of a line. But you would find them using the same method. So, rate of change, we also call it m, or slope, equals to this ratio, which is called the change in y, or the rise, over the change in x, or the run. And to find rate of change or slope, you would need 2 points from a line, or 2 ordered pairs, and you would take the x coordinates, and those would be subtracted on the denominator. So here's my x coordinates. I would subtract those as my denominator, and then I have my y coordinates, and I would subtract those as my numerator, and then I would simplify the fraction as best I can. So we're actually going to come back to this one. First, we're going to find the slope, which is way over here. So we're going to find the slope first. This is just taking 2 points, or 2 ordered pairs, and we're asked to find the slope. So we need to take our x values and subtract, which is going to be our denominator. And we're going to take our y values, and since I started with the 3, I'm going to start my y values with the 6. So 6 minus 8. And then I would simplify. So 6 minus 8 would be negative 2. 3 minus 4 would be negative 1. And that would make this actually a positive 2 over 1, since both are negative. So my answer would be just 2. The next one, I would do the same thing. Subtract my x's. That's my denominator. So it's 6 minus, and then you have minus a negative 2. And then we have 7 minus 7, which gives us 0. So 0 over, this becomes 6 plus 2, so 0 over 8, which simplifies to just 0. And then the next one, again, we are subtracting our x's as our denominator, so negative 2 minus negative 6, and our y's as our numerator, so 2 minus 4. That's going to give us negative 2 over, this becomes plus, so negative 2 over 4, which we can simplify to be negative 1/2. And that would be our slope. One more. We have 6, 3, and 6, 7. We're going to take our x's and put that as the denominator, 6 minus 6. And then our y's are our numerator, 3 minus 7. So that becomes negative 4 over 0. Now anything over 0, we actually write this as undefined. It is an undefined slope, which actually also means that it's a vertical line going through the x-axis. Here I just have some pictures of slopes on a graph. You always read the graph from left to right. So if I'm looking at this graph from left to right, my line is going up. Okay, this would be my y-axis, this would be my x-axis. So my line is going up from left to right. That would make this a positive slope. Then again, I have my y-axis and my x-axis. This time from left to right, it's going down. The line's going down, so that would be negative slope. Then we have, again, our y-axis and our x-axis. And I'm looking at the line. This is a horizontal line through the y-axis, so this would be considered a 0 slope, and then I have a vertical line through the x-axis, and that is considered undefined slope. On the same idea as finding the slope, this time we need to find one of the missing coordinates. They give us the slope, so we're going to use the slope formula, but we're going to solve for a particular variable, in this case r. So we're still going to subtract our x's as the denominator, so -2 minus r. I'm going to write this on the next page, actually. So -2, -2 minus r. And then I'm going to subtract my y's, 6 minus -4. I'm going to be putting it equal to the slope. The slope was m equals -5, so that is -5 over 1. And I'm going to solve. I can either cross multiply here, or I can just guess and check. I would actually cross multiply. That would probably be the best way to do it, because -5 is the simplified version of this, so it would be harder to guess and check. So if I were to cross multiply here, I have 6 plus 4, which is 10, times 1, which is just 10, and that would be equal to -5 times -2 minus r, and that would be put in parentheses. So let me make this smaller. So I'd get 10 equals -5 times -2 minus r. And I would distribute the -5, because my goal is to solve for r. So I have 10 equals +10 plus 5r, which would mean I would need to subtract 10. So I have 0 equals 5r. Divide by 5. 0 divided by 5 would be 0. So r in this case would be 0. Now we have another one right underneath it, r comma -6 and 5 -8. We're going to solve for r, so we're going to use the slope formula to help us set it up. Our denominators are the x's, so r minus 5. Numerators are the y's, so -6 minus -8, and that is equal to the slope, which is -8. So I'm going to cross multiply, and I get -6 plus 8 here, which gives me 2, and 2 times 1 would be 2, and that's equal to -8 times r minus 5. So we have to distribute, and I have 2 equals -8r plus 40. So I need to subtract 40, which gives me -38 equals -8r. So I would divide both by -8. So I have 38 divided by 8, which is actually going to give me a decimal. And it's going to be positive because I have two negatives that I'm dividing by. So r, in this case, would be positive 4.75. Now we're going to go back to rate of change. So we found the slope, we talked about the slope, and now we're going to go to rate of change. So we're looking at the table here, and we need to figure out what the rate of change for this table is. So it shows the tiled surface area changes with the number of floor tiles. Okay, so that makes the area of the tiled surface our y, which is listed, and the number of floor tiles are x. So these are just ordered pairs, 3, 48, 6, 96, 9, 144. So if I'm going to find the rate of change, I'm going to just need 2 consecutive points, and I'm going to use the slope formula. So 348 and 696 can be our 2 points from the table. So I'm going to take the y's and subtract. That's our numerator, and then my x's and subtract. That's our denominator. So 6 minus 3 is 3, and 96 minus 48 is 48. And then we need to know 48 divided by 3, we can simplify, which is 16. So the rate of change is 16. Now I need to think about what that is in terms of the meaning of the rate of change. Okay, so I need to go back to the table. And if each time the rate is going to be 16, that means that the number of floor tiles is going to be 1, and the area of one floor tile then would be 16, or 16, I believe, inches squared. So if we think about this as a fraction, 16 is your y value, 1 is your x value, which is why I said that for every one floor tile, it's 16 inches squared as the area. So that's how we would describe the meaning. Here, we want to refer to the graph on the next page. So first we're going to see, without calculating, we need to find the 2-year period on the graph that has the least rate of change. So it goes up the least steep amount, basically. And then we need to calculate to verify. So we're going to find the slopes for each point, or each 2-year period. So if we look at our graph, we have 4 points here, and we need to figure out what the least rate of change is. So between 2000 and 2002, or between 2002 and 2004, or between 2004 and 2006. So to figure that out, I'm going to rule out 2004 to 2006 because that's the steepest incline. It looks like between 2002 and 2004 is the least amount of incline, so that's going to be our least amount of rate of change. To check that, we need to find each, in between basically, each slope. So I'm going to use the points 2000 for x, 317. That's going to be our first point. Second point would be 2002, 324. Third point is 2004, 325. And our last point is 2006, 335. And I'm going to take each set of 2 points and find the slope between them. So if we start with the first 2 points, we have 2000, 317. And 2002, 324. So we need to find the slope. We need to subtract the x's as our denominator. and the y's as our numerator. Notice that I tried to make it positive, so since I started with 2002 for my x values, I also needed to start with 324 for my y values. So 324 minus 317 is 7 over 2002 minus 2000 is 2, so 7 over 2, which is 3.5. So that's my first set of rate of change. Now I go with my next 2 points. 2002, 324 is going to be used again, and then that's going to be with 2004, 325. So again, find my slope, or my rate of change, my y's over my x's. So I get 1 over 2, which is just 0.5. Okay, and then I'm going to continue with the next 2 sets of points. So to erase this, so here's my last 2 sets of ordered pairs, 2004, 325, and 2006, 335. So I'm going to again find my slope. Notice up in the top right-hand corner, I've already listed my 2 slopes that I've found. So I have one more slope to compare, so I need to find the least slope, or the least rate of change. So 335, I'm going to subtract the y's over the x's, and I'm going to get 10 over 2, which simplifies to 5. So my 3 rates of change are going to be 3.5, 0.5, and 2. So I need to find the lowest one. Well, that's going to be the one that's 0.5. So in between 2002 and 2004, which is what I originally guessed because it looked like the least steep part right here in our graph. In the last 2 problems, we need to determine whether each function is linear. So we're going to look at the table, and basically we're going to find the slope 4 different times. So I'm going to find the slope in between these 2 points, in between these 2 points, in between these 2 points, and in between these 2 points. And if these slopes are all the same, then it would be linear. If they are not the same, meaning they don't have the same rate of change, then it's not going to be linear. I'm going to do the same thing with the next one. Find the slope for these 2 points, and these 2 points, these 2 points, and these 2 points. So we're going to find the slope 8 times. So if you look at what I've just did at the bottom of your screen, I've just found the slope for the first 3 sets of ordered pairs. So for negative 311 and negative 215, the slope would be 4. Then I did it again for negative 215 and negative 119, and that's also 4. Then I did it one more time, negative 119 and 123, and I got my slope of 2. So since I've gotten a different slope now, I can actually stop and say that this is not linear. So I'm going to try again with the next set of numbers to see whether I get the same slope for all of those. So as you can see, I just did the first 3 slopes for the next table, and I got negative 5 over 3, then I got 5 over negative 3, and also 5 over negative 3. So it doesn't really matter that the negative sign is either on the 5 or the 3. So it's the same thing. The whole thing would be negative. So far I have the slopes all being negative 5 over 3. So I'm going to try one last one. So 16, 0, so I'm going to subtract 16 minus 11 as my y's, and 0 minus 3. And I'm going to get 5 over negative 3, which is making all of the slopes that I got for this table negative 5 over 3. So it has the same rate of change, so I would say yes, this is a linear, this function is linear. And that concludes lesson 3.3.